Okay, I'm going to redo section 2.1 on the tangent ratio because I just didn't feel like it went smoothly in class on Friday, and I want you to have the opportunity to go back and look at it again if you want, so that it does make sense for you. So trigonometry is the study of triangles and using triangle properties to learn more about triangles and make predictions about triangles. So what we're going to do right now is we're looking at these triangles. Well, there's only one on your screen right now, but there are two triangles on the page. And if we measure the length of angle of line AB, okay, if we measure AB, we get that's 70 millimeters. And if I measure BC, that is 136 millimeters. And the ratio of AB, 70, to BC, 136, is 0.515. We're not going to look at the inverse right now. Also, I measured this angle, and it is about 28.5 degrees. Can't measure it any more accurately than that with the protractor that I have. Okay, where's my mouse? Okay. Let's look at the second triangle. This is a similar triangle. This is also 28.5 degrees. And the measure of xy is 51 millimeters, and yz is 99 millimeters. And I encourage you to do the measurement on your own paper. Should be pretty close, might not be exactly the same because it went through the photocopier. Okay, so the ratio of xy, which is 51, to yz, which is 99, 0.515. I didn't make that up. That's how it's supposed to work out. I think the numbers I used in class were numbers that students had measured and were perhaps not as meticulous as I was. Okay, and then we're not going to do this. So what I want you to see is that for any triangle, any two triangles that have the same measure of their angle, the ratio of that one side to the other side is the same. So we're going to write that down on the next page. We're going to go to the next page. We're going to skip that. The ratio of the length opposite side angle A to the length of the side adjacent to angle A depends only on the measure of angle A. Not on how large or small the triangle is. That doesn't matter. We saw that on the first page. And this ratio is called the tangent ratio. Of angle A, and it's normally written as tan A. And it's usually written as a fraction and then as a decimal like we did on the first page. Now I'm just going to pop back up to this little explanation up here. This is really important. When we're talking about adjacent and opposite sides, it has to be adjacent to something and opposite from something. So in this first triangle, we're talking about angle A, which is here. So this side is opposite angle A, and this one is adjacent to angle A. And in the same triangle, because this is the same triangle, it's just copied, this is angle C. The other side is opposite angle C, and this one is adjacent to. Adjacent means beside. The other thing that both of these triangles have is the hypotenuse. Which is always, hypotenuse, is always opposite the right angle. And all of these things we're talking about right now, all of this trigonometry we're doing this year is only about right angle triangles. So the hypotenuse is always opposite the right angle, and then we have adjacent and opposite, depends on which angle we're talking about at any given time. Okay, I will come back to this, or maybe not. Let's do this. Determine tan x and tan z in this triangle. So tan x equals the length of side opposite angle x divided by the length of side adjacent to angle x. We shorten that to opposite over adjacent. So in this triangle, opposite x is 6, adjacent to x is 12. That reduces to 1 over 2, and we express it as a decimal as 0.5. So the value of tangent of x, or the tangent ratio of x, is 0.5. No units. There are no units for tangent. Okay, now let's do for angle z. And I'm going to do this in a different color. And do it in red. This time z is our angle of interest. So it is, tangent of z is the length of side opposite angle z divided by the length of side adjacent to angle z. And we again go opposite over adjacent. And this time our opposite is 12. So this is 12 over 6, reduces to 2 over 1, or just 2. And the tangent of z is 2. Now, where that is useful is that I can take that number and I can go to a time table, our tangent table. Let's see if I can actually just do that right now. I may edit this. I may need to edit this, but let's try it. I can bring this in here. I think it's still going to record that, so I'm going to Google tangent table. So, whoops. Is it page? Okay, I have a tangent value of 2.0. So if I find look at the tangent value on my table is going to be here, or here's between here, so it's about 63.5 degrees is how big that angle should be. So let's go back to our drawing. Does that look like that's a 63-degree angle? Kind of does, doesn't it? And if we go back to this angle up here, where we got a tangent value for angle z of opposite over adjacent of 0.515, and let's go back to our table of 0.515. 0.515 would be in here between 27 and 28 degrees. Did I write that down right? Yeah, you know what? I wrote this wrong. This is actually 27.5 degrees. So let me fix that. This is like the 4th time I've recorded this video. Playing around with the software that I've been using, so this is actually 27.5 degrees. That is actually the value that I measured it at, 27.5 degrees. And that's also the value that the table tells us by looking up tangent. So any triangle that has a tangent value of 0.515, the angle that's the tangent of will have an angle of about 27.5 degrees. And when you use the tangent button on your calculator, what it's really doing is looking it up in a table for you. The tables are much more complicated than that one if they go to multiple decimal places. That was just a simple table. Okay, let's do that. Let's use the tangent button on our calculator now. So using the tangent ratio to determine the measure of an angle, we're going to find measures of angle K and angle N to the nearest tenth of a degree. So we're going to start with k, so we're going to go tan k equals opposite over adjacent. Oops. Tangent of k equals opposite is 9 and adjacent is 13. So tan k equals 0.692. I just did that on my calculator, 9 divided by 13. Okay, now I have to untangent it. It's the tan to the minus 1 button, or inverse tan button. I'm not sure, the calculators are all different. So you'll need to figure out. On mine, it's a shift and then the tangent button. If you need help, I'll help you in class to show you where that button is on your calculator. So we talked about dividing as being unmultiplying something, and tan to the minus 1 untans it, if you will. So we're left with k on this side. And our calculator gives us a value of 34.695, and some other numbers. The question has asked us to go to the nearest tenth of a degree. So we're going to say k equals 34.7 degrees. Okay. And then let's do angle n. So the tangent of n is opposite over adjacent. Please write that down every time. That's how you remember it, and it's how you reduce silly errors. Tangent of n. Talk about silly errors. Tangent of n. The opposite is 13. Adjacent is 9. So tan n equals 1.444. And then I do my inverse tan. And inverse tan. And I'm left with n equals, and my calculator gives me a value of 55.305. So n equals 55.3 degrees. And then as a check, m plus n plus k should all equal 180 degrees because this is a triangle. And m is 90 degrees, we can tell because it's drawn as a square. And plus 55.3 plus 34.7. Yep, that equals 180. So we didn't make a silly mistake. Okay. Next example. Using the tangent ratio to determine the angle of inclination. Clyde River on Baffin Island, Nunavut, has a latitude of approximately 70 degrees. The diagram shows the side view of some solar panels. Determine whether this design for solar panels is the best for Clyde River. Justify your answer. So angle of inclination means the angle going up. So this is the angle we're talking about. And now pay attention because this will probably be on your provincial exam. You need to know that the optimal angle for your solar panel is equivalent to your latitude. So for this to be optimal, it should be 70 degrees. So we need to find out what the angle is. So all we know how to do is tan. So let's go tan. We need to label our angle. So label it A. So tan of A equals opposite over adjacent. So tan of A equals, opposite is 208 over, adjacent is 70. So tan A equals, I didn't actually do this one. I need to actually find my calculator for this one. 208 divided by 70 equals 2.9714. And then I need to go tan to the minus 1 and tan to the minus 1 to get A equals 71.3999. degrees. So there's our answer. That's how big the angle is. Is this best for Clyde River? Let's say this is a very good angle. Very good design. For Clyde River. Because it is very close to 70 degrees. Okay, there you go. That was much calmer than in class. I will do example 4 is actually done. It's in a separate video.